Good afternoon to all. My name is Ramanathan. I'm working as a assistant general manager in Mitsubishi Electric India. So I'm taking care of digital transformation um, team in Mitsubishi in India. So today I'm going to present in the digitization part how the digitization can be perfectly done for the EV manufacturing sector, mainly into the production line. So with that, I would like to start my presentation. So I think all of you know very well about the industry's evolution, start from the 1.0 to 4.0. Right now we are at 4.0. So now it's moving towards the society 5.0. In when we started in 1784, the industry one it started with manufacturing the power by using the steam, then moving into the 2.0 where the mass production gets started where by using the electrical energy, then setting up into the automotive sector by using the assembly lines. Where once there it started manufacturing of the automotive vehicles at the end of 2.0. And in once it moves into the 3.0 where the automation and the electronic revolution has happened, where the silicon has plays a major role for making the chips and sizing the electronic parts, where the automation plays a major role for the manufacturing into the production line. So where the relay logic gets changed into the PLC based control systems. So it's meant for the mass production line. When moving into the 4.0, now we are at 4.0 where the at the end of the 3.0, uh, due to the strong revolution of the information technology, so it collaborated with the automation systems where we give as a complete the production line and merged with the IT. So with that monitoring in the remote places, and now it's moving into the digital twin, how the remote monitoring, how the remote through the operations and controls can be achieved. So now it's moving in the kind of the IoTs, Internet on Things, the sensors enabled into the remote connections and getting the data through the wireless and wired network, then remotely monitoring the operations and giving the maintenance instructions, giving the control systems. Now it's moving into the 4.0. So the we as a Japanese we called as a e-factory kind of a concept. It's nothing but American they called as a smart manufacturing paradigm, where the European called as Industry 4.0. We as a Mitsubishi, how the e-factory make the bridges into the seamless production line. Just we will going to see in the forthcoming slides. So this is the evolution of the computing. So from the mainframe, then client server architecture, then by using the mobile on the cloud, then now it's a edge intelligence. So edge intelligence, in the started with the 2020 after the pandemic, how effectively, it's put up the push the requirement towards the distributed computing, how the remote peoples can operate the factories and how the giving the operating instructions, how monitoring the productions, how effectively making the control into the manufacturing sectors. So this is some kind of the industry 4.0, how the IT and OT layer merged together, and because of the advanced cyber physical systems. So how the networking and edge computing, then now it's moving, the directions are in the society 5.0, going into the artificial intelligence. So how the making the machine learning algorithms and deep learning helps to predict the equipment life cycle. Like a human, now it started predicting the equipments also by analyzing about its kind of a vibration, temperature and current. Those parameters capturing and doing the analytic part, and predicting the life cycle of the equipment. So this is the direction it's moving in this future. So this is we called as a either we called e-factory or industry 4.0. So how the solutions get originating from the production shop floor? Just the pyramid in the bottom layer level 0 talks about where the equipments are there, making into the production line. So where in the manufacturing line, the equipments collect the data from the sensors and giving the control to the motors, actuators, then valves, and the different kind of sensors, like it can be a proxy or photo, then limit switches, encoders. Those are all the input devices giving the actual data. It can be a sensing, or it can be some kind of a prediction, or it can be a feedback control kind of a systems. It supports for it. Then next level, how the integrate the man and with the equipment, man machine interface. So in that started with some kind of, we has a terminology called as a graphic operator terminal, or some people called as a MMI, man machine interface, or human machine interface, and how the productions can be monitored effectively. Man machines or HMIs can be used for monitoring the equipment level, but how we can monitor the productions? So where we provide as a some kind of a standalone systems for the shop floor levels. It's some kind of the production monitoring, then maintenance models, quality models, then traceabilities, and some kind of add-on systems for visualizing the productions and maintenance alarms and quality information systems. And in the top, where the actual ERP, enterprise resource planning, gets um, works, which captures the demand from the users, then how the planning capture and deploying into the actual scheduling into the down level, where we provide as a the kind of mesh based systems solutions, and it transfer the scheduling seamlessly into the bottom production environment by using the digitalizing the network and architectures. So what the e-factory, the solutions, how it synchronously or seamlessly supports for the lean manufacturing technology. So there are the data can captured from the equipment and then putting into the top, and then top the control command putting in the pushing into the downside. So the data collectors, concentrators plays a major role, which is very important. So where some data can be collected through the hardware devices, and some can be collected and transferred through some kind of, it's a bidirectional way of communication. Some will be connected through the software concentrators by using Takabeshi or Kepler OPC servers, plays a major role on it. And in the top, now, after collecting and giving the control command, so there are so many data. So some data may be relevant, some data will be irrelevant. So what that's our system bridges the top and the bottom equipment in a seamless way, and also discarding the unrelated informations, and then capturing the useful information and performing the analytic part, and then based on the analytic result, how the further case and activities can be carried out in terms of improving the line side efficiency or productivity, so that we provide as a complete solution. And in addition to that, how this monitoring and how these control actions can be provided from the remote level, so where the digitalization plays a major role, called as a digital twin, how we can give the operating instructions based on the SOPs, and also capturing the data and then making the traceability, then monitoring in the remotely. So this kind of the complete the solution top to end we provide as a complete digitalization part. So what the functions had different kind of models. As I mentioned, it's having almost 15 models. So start from the enterprise portal, then the data acquisition, then making into the uh, production monitoring informations, traceability, then for the manufacturing management systems, and for the for making the seamless manufacturing, then raw materials, the inventory control, we called as a warehouse management system, where it pull the materials and also takes care supports for the FG part also. So these are all standalone models. When we integrate the complete models, how effectively it can be deployed into the, either it can be automotive or EV manufacturing plant. So this particular, the slide talk about the slide number 8 talk about the automotive. Uh, we what we provide a solution for the complete plant level, especially for the automotive production environment. It start any automotive industry. It can be a four-wheeler or two-wheeler or three-wheeler. Start from the stamping, moving into the welding, painting, then vehicle assembly. So where making the synchronizing from the stamping to the vehicle assembly line, and also for the how to make the synchronization with the powertrain shop, where it's having the casting, machining, and the assembly shop for the engine and transmission part assembly. Then pulling the engines and putting into the vehicle assembly line based on the JIT concept for the part supply synchronization like that. It provide as a complete mesh manufacturing execution system for the complete automotive. This is mainly for the IC engine manufacturers. Similar to that, we also provide for the EV production environment. In the EV, most of the for the press shops, it will be outsourced from their part suppliers. So it starts from the weld shop. Some cases there will be a press shop, obviously, and mainly it starts from the weld shop. And for the paint, moving into the paint, then the general assembly line. So for the weld shop, we provide as a production control systems where it can connect with the your ERP and then capture the planning and then deploying the scheduling into the weld shop for the main line, underbody, overhead lines, and then capturing the quality data also for the maintenance, materials parameters, then giving the inventory feedback systems for replacement part. And similar for the paint shop, once the body comes into the paint shop, then it checks for the gate check for the weld line, whether it's the quality is become okay, it's moving into the paint line. Then for the paint again, the PTCD or the paint shop, the data transfers in line with the serial number, then capturing the process parameters like degreasing, phosphate, then current, temperature for the tanks, when the transporters moving into the carrying the vehicles in the carrier, putting into the different tanks, then mapping those parameters, process parameters for the future traceability. And then for the general assembly line, it starts from the VIN number generation and then moving into the vehicle assembly area, then synchronizing the sub-assembly line, then supermarket, putting the parts into the readily available based on the 4 hours or 2 hours duration with respect to the plant takt time, making the parts available, then making the synchronize the productions, and then end of the line checking the quality parameters. Where in the assembly also it can be AGV based, we give us a digital kitting systems in line with the ASRS system for storing the batteries, converters, and chargers, and pulling the materials through AGVs and putting into the line side. Like that, we give as a complete, end-to-end solution. And similar, this same is applicable for like engine assembly for the battery assembly line also. So, which can be explained detail in the forthcoming slide. And this is the in the EV production vehicle production line, we provide as a complete digital solution called as a plant view. So the plant view start from the raw materials incoming. Once the GRN done at the ERP, then this plant view systems takes care of the complete manufacturing and putting into the warehouse, part of a stores management, put away sequence take place, and then once the vehicle enter into the assembly or into the paint shop, then pulling the material from the warehouse, then making the parts available into the production environment, production line, and moving into the each shop. What we provide as a solution for the shop level press, weld, paint, and assembly, where the production monitoring and production control systems, and also it captures the equipment management and the OEE, MTTR, MTBF, so those kind of parameters. Then the quality models for checking the quality gates. So in the quality gates again, before the vehicle moves into the paint shop, it checks for the quality parameters, whether within the limits or sometimes it goes for the rework. Once the rework done, then again putting the vehicle into the next station. In the either it can be paint or assembly, wherever it be applicable. Sometimes it one gets due to some issue, maybe some in the production environment, some issue happened, some dent or something is happened, then it goes for the rejection completely, considered as a scrap. So like this, it captures the complete data and then providing the informations in line with the vehicle tracking systems. It maps all the quality data for the net runners with respect to the VIN number. It maps the data. So tomorrow, if you want to check the VIN number, it can retrieve all its process and the quality parameters. And this is now I'm moving into the some of the our successful case studies what we have deployed to the EV manufacturing line. This is mainly for the two-wheeler manufacturing line. So where we provide as a end-to-end solutions. So it starts from the raw materials storage and making the put away a part of a WMS. So this particular case of a WMS system, making the effective storage where we have developed some kind of mobile apps. Through that they can store it properly and then they will scan it. So some kind of interlocking for the POCA case for the storages with respect to the correct bin, and based on the ERP integration. So it can be SAP or it can be Ramco or it can be Microsoft Navision or Oracle based ERPs. So with that we capture the plant, the production plant, then the serial numbers will come into the, either it can be a press or weld shop. So once it moves into the body shop, then the serial number will be marked into the body. Then the body shop operations, the robotic welding and all the operations, done in the body. Then final there will be a quality checks. Once the quality checks is become okay, then moves into the PTCD area, then moving into the paint shop. Then after the paint, with respect to the serial number, it maps the process parameters in the paint shop. Then once it moves into the assembly, then VIN number will get generated. So with respect to the VIN number, then all the assembly operations will get performed, including the motor, chargers, wire harness, everything, windshields, rear side, front side. So then assembling all the operations in line with the supermarket or the sub-assembly line, then moves into the EOL for the end of line final functional testing. Then for the moving into the final storage for the FG yards. Then after once the load slip get generated from the ERP for the truck loading, then retrieving the FG from the yard, where we have developed again the app based systems. Through that they can check, and then it make the loading into the truck, then giving the feedback of the serial number loading into that. Accordingly it will adjust the inventory also, where we have developed the system here, the software model called MRP, which is having the material requirement planning. So with respect to the FG gets FG code get generate at the end of the line in the assembly shop area. So automatically the inventory gives the triggers, then the replenishment happened into it will issue the appropriate orders to their part suppliers, and making the inventory will be available for the production. And also this is having the production and scheduling planning, where it's having the advanced scheduling. So based on this particular case study talks about, so it captures the demand from the distributors of the manufacturers and available inventory. It will prepare the best fit with respect to the forecasting and all seasonal forecasting. It fixes the best fit, and this best fit again it transfer to the ERP. Then it will issue the serial number. So like that, we have little advanced level of we have the algorithms we put up into the production advanced production scheduling planning model. And these are the different in the digitalization part, how the plants get synchronized with each shops. These are the different function models which get deployed for the digitalization part in the EV production line. And this is some of the warehouse, how the raw materials get storage, how the POCA case making into the operations, and how the material gets issued into the production line with respect to the win numbers. So where the operator and supervisor can also see it from the storekeepers, in their Android mobile, what are the parts or request has come, how the replenishment happened in the 2 bin or 3 bin systems. So these are some of the images. So how the apps plays a role, how the remotely this can be monitored. So like this kind of for the even the finished good, what is the plan for the day, or in the truck what are the FGs need to be loaded. So where what with respect to the plan, what is the progress, so where it can be monitored the remotely by using the cloud computing technology. Similar to that, this is the particular solution for the battery assembly line, where same like the vehicle production, it starts from the cell inspection, then the battery module assembly, where we put our different kind of robots making into the effective assembly line, carrying the robots and fitting into that, and battery pack assembly, where the robots plays a major role for the cell unboxing, cell loading, then module cell insert, then module cell insert for the array, plasma cleaning, cell handling, glue dispensing, kind of the complete handling, how fast it can, how the productivity can be improved by using the robots, and how also it ensures the quality things by using the vision based systems, by using vision cameras, whether the parts has been assembled in that with respect to the serial number or not, then capturing the serial numbers, then mapping into the batteries, then these batteries will be once it get assembled into the assembly line, it mapped the complete with respect to the bin number. So like that kind of end-to-end traceability, quality, material, modules plays a vital role. And these are the different software metrics which we have developed for the battery and vehicle line, production quality, TPM losses, analysis, how the losses can be captured, how it can be deployed into the lean manufacturing methodology. So this is some of the things, downtime, stop factor, then cycle time, then changeover time, setup time, like that, we for the TPM losses, 14 losses we capture, then do the analytic part. So this is some of, the models, and this is the case study for the battery assembly line. So in depth, it's talk about how the assembly takes care in the battery line. So how controlling is happening, how collecting the data and transferring to the plant MES, and next moving into the ERP level, how the visualization is happening. So this is some of the dashboards for the battery assembly line dashboards. Moving into that for the next shop levels. And this is some of the case studies for the uh, standalone systems for the GA lines, how the GA line, the vehicle is getting assembled, and then how the traceability, the production models plays a role. So this is some of the system overview of the dashboards for the this. Sometimes if there is a startup plant for the EV line, so they may not be able to implement the end-to-end system. In such cases, we can also offer a cost-effective standalone models like the production monitoring systems, production information systems, and some kind of ASRS system for the automatic storage and retrieval in line with the digital picking system, where with respect to the talk time setup in the line, so it pull the batteries and different parts from the stores, putting into the AGVs automatically, making the high production line environment. So this is some of the case studies, and this the case study talk about the system for the paint shops, transporter logic for the PTCD and the paint processing, capturing the process parameters, and then storing into the mapped with the serial number, body, the tank level, the temperatures level, and also the process parameters, phosphate, degrazing. So this kind of current temperature in the booth. So the complete mapped with the production serial number, and this is the dashboard where it can be monitored either from the plant shop level office as well as from the remotely also it can be monitored. And this is after the capturing the data, how the data analytic part will be played a role, and how by using the statistical tool, what is the line efficiency and the overall equipment efficiency get captured with respect to the line stoppages. Based on the analytic, it gives the result. Based on the result, the further improvement on the productivity and line efficiency carried out. So this is some of the prediction management algorithms. So it's mainly deployed for the identified critical equipments or motors, where we install some kind of IoT based sensors capturing the vibration, temperature and current parameters, and also it capture the energy parameters also for the equipment levels and the conveyors, motors. Based on that, whether it is the ideal time, what is the consumption, running time, what is the consumption, and also each shops the consumption of water, gas, steam. So this kind of the complete utility management system also we used to provide as a solution for part of the production line. And this is the thing, IoT based sensor which monitor the or I can say the health, check the healthiness of the equipment or motors. And this particular sensor capture about the vibration, temperature parameters, and then we developed the fast Fourier transform based algorithms. And in this statistical tool, based on the vibration level of the frequency domain, it segregates the whether it detects the early warning signal it used to provide, whether it's sometimes it goes into the unbalancing, misalignment, bearing defect or cavitation. Based on this warning signal, the maintenance team can take appropriate action in order to prevent the complete line stoppages or the production line stops. So it can prevent. So such kind of early warning signals, we used to deploy this kind of systems for the EV companies as well as for the major automotive customers in India. And these are the how the analytics and the graphics trends, some of the sample images shown in this particular slide. And this is the utility dashboard screens, the consumption, and this is the real time monitoring the system dashboards. That's all from my side. Thank you very much. Thanks for listening. Thank you.